This is VISHWAJEET Bharadwaj. Today I'm going to be solving a problem in GFG. So the problem name is nth natural number. It's a hard problem. So given a positive integer n, you have to find the nth natural number after removing all the numbers containing the digit 9. For example, if you see this test case, n is equals to 8, the output is 8 because the first natural numbers are 1 to 8, so no digit contains 9. So if you see the other test cases like this, let me show you an example. For example, when n is equals to 20, the output is 22 because we have to skip two numbers that contain 9, which is 9 and 19. So total number of numbers that are skipped are 20. So the output would be 22. So the next test case is 35. So the output for this would be 38 because the numbers you would be skipping was 9, 19 and 29. But for when we increase the size of n, we can see that the number of elements to skip becomes immensely large, right? So here in the case of 94, we have to skip these many numbers. That means 20 numbers are getting skipped. So the logic that we use is basically using the divide operator and percentage operator for dividing and getting the remainder. It's basically a remainder and divide logic that I've applied here. That was not the brute force approach. The brute force approach is nothing but O of n. You have to run a loop, or run a loop of size n, and if any number contains the digit n, then you can see the code over here. So I've run the loop, while loop, and I'm terminating the loop whenever it reaches n, whenever it reaches the given input. So if 9 is not present in that number, then I'm using count variable for that. So basically this returns the correct answer, but the time complexity of this is O of n. So this is not the optimized code. So for the optimized code, we go for using the division operator and the percentage operator, finding the remainder and then dividing it. So let me explain that code too. So here is the optimized code for that. So I'm storing the result in a variable called result, and then I'm using m as the place of the digit. For example, ones, tens and hundreds to indicate the place of that particular digit. For example, here if we see in the case in when n is equals to 35, 35 mod 9 is equals to 8, right? And then so after performing after using the percentage operator, I get remainder as 8, and then I have to perform a division, right? Integer division. So integer division, I have set n double slash equals to 9, so that's where I perform the integer division. So 35 divided by 9 gives 3 point something, so I've rounded off, I've performed a floor function, so it is 3. So since it is in the tens place, so 3 times 10 is 30. So the final answer is getting added. So I'm adding each intermediate result to the result variable. So the result gets updated each time we run the loop. So this gives us the output as 38. So the 35th natural number is 38. Similarly, if we look for this test case, we can see that the 20 numbers are getting skipped. So let's check let's check if the answer is correct. So 94 mod 9 implies 94 mod 90, which is equals to 4. Then 94 is divided by 9, which gives us 10, right? And 10, it's in tens place. So this 10 in tens place. So I have to multiply by 10, which gives us 100. 100 mod 9 is 10. Okay, and then again so you can see that we have 10 here, and then for the next iteration, this 10 in this is the intermediate result stored. So this 10 gets divided by 9, so integer division, and we get 1 as the result. So 1 mod 9 is equals to 1. So this is for the hundredths place. This is ones, this is tens, and this is hundreds. So 1 mod 9 is equals to 1. 1 into 100 is 100. So we sum all this. I mean, it's intermediate, in each step the intermediate result is added to the variable result. So 100 plus 10 plus 4 is equals to 114. So if we can see, we can observe that 114 minus 94 is nothing but 20. That means here we have seen that 20 numbers are actually getting skipped. So let's check this. Let's check if this code works for all the test cases. So I've commented the old code because it runs for O of n time complexity, but the new code, since I'm using divide operator each time, so we can observe that this code this about the optimized code runs for O of log n, more accurately O of log to the base 9n. So let's just check whether it's valid for the test cases. So yes, so as I said, for the custom input, well, I've actually changed the custom input. Let's check for some other number. So let's just change the input and then check. So you can see that the test case has been passed. So let's just submit this code and check if all the test cases have passed. So it's queuing. So we can see that all the test cases have been passed for this code. So I've commented the old code snippet, and then this my original, my optimized code has been submitted, and all the test cases have been passed. So yeah, thank you guys.